So welcome back. Again, we're going to work with some complex fractions, and again, our objective is to simplify these guys, make them look a little bit more simpler. So one of our strategies is to identify the denominators. So if you look at the top fraction, this would be the denominator at the top. If you look at the bottom fraction, these would be the denominators of the bottom fraction. So notice how we can actually have algebraic expressions as denominators. So this takes it to a different level. Let's look at the 5 and the 25. We should recognize the common denominator between a 5 and a 25. If I look at my multiples of 5, 5, 10, 15, 20, 25 is a multiple of 5, and of course 25 is the first multiple of 25. So 25 is a common number there. So what we need as our LCD is I need a 25, and I also need this m minus 1. So the LCD in this problem is that 25 and that m minus 1. So what I'm going to do is multiply the numerator and denominator both by those two pieces. So I'm going to multiply a 25 times m minus 1 on the top. I'm going to multiply this bottom also by a 25 times an m minus 1. So on the top, what we pick up on is this m minus 1 and this m minus 1 actually are going to divide out. Since this is on the top and this is on the bottom, we know that if you have like numerator and denominator, those just divide out, so I can just cancel those out. So what I'm left with on the top is 16 times 25. So I came to, off to the side here, 16 times 25. And that's going to give me 80 on the top here. So I got 12, 2, 3. Looks like that's going to be 400. So the numerator actually turns into then a 400. So let's now turn our attention to this bottom piece. So this bottom, we do see that this 5 will go into 25 5 times. And then I actually got to multiply 16 times 5. So that 5 actually divides out there. That leaves me with 5. 5 times 16, that would be 80. And we also have this m minus 1 going on that has to come through here. So that m minus 1 has to go with this term as well. So 5 times 16 is 80. And I'm just going to leave that m minus 1 like it is for the time being. This next part we pick up on is this 25, again this has to get reloaded. So this 25 goes to 25 one time. So all I'm left here is then is a 16 and an m minus 1. So it looks like the numerator is fine. I still got some more to do on the bottom. So I have a 400 over then, and I can use the distributive property to remove these parentheses. 80 times m is 80m. 80 times a negative 1 is a negative 80. And a negative 16 times m is negative 16m. And negative 16 times a negative 1 is a positive 16. So it looks like, in turn, the 400 is still left on the top. And on the bottom, we should see that 80m and a negative 16m are like terms. So again, I can focus on those coefficients, 80 and a negative 16. That's going to take me down to, looks like a negative 64, or a positive 64. 64m. And then a negative 80 and a positive 16 there. Looks like that's going to give me a negative 64. So I'm going to have a 64m. Those two terms are going to give me a 64m. And then that's going to give me a, looks like a negative 64. And so for the time being, we're going to leave that answer like that. As we get further on, that actually can be simplified a little bit further. But at this point, let's just leave it in that notation. So I have 400 over 64m minus 64. And we'll talk later on what else we can do with that one. Notice how this math gets kind of busy. There's almost no choice but to kind of do some stuff mentally. So looking at this example, we have to identify the numerator, we have to identify the denominators. So on the top, you kind of see that this 8 and this a squared are the numbers on top. there's really not a denominator on the bottom fraction, so that's not really a complex piece here, just this part. So we pick up on our LCD, all we need is an 8 and an a squared. So our LCD becomes this 8a squared. What I want to do with that then is multiply by the LCD, which means I want to multiply the top by 8a squared, and I want to multiply this bottom by 8a squared. And remember, we're using distributive property. This has to go multiply to this, and this has got to multiply to this, these pieces. What we'll pick up on is this 8 is actually going to go into 8. 8 divides out. A squared times a gives me then a to the third power. Because if you have a times a times a, that's a to the third power. On this next example, notice the a squareds divide out, and you have then 8 times 4, so it's going to be a minus 32 there. On the bottom, we just straight multiply. 4 times 8a squared is going to give me 32 a squared. So that's what we're looking for as far as a little bit simpler form than this. So I can change this complex fraction into something that looks a little bit more familiar to us. Okay? So hopefully you'll find these examples helpful. And again, we have more to do with these, but it's a good introduction of kind of playing with the distributive property with fractions. So stay tuned.